So this is actually the internal diagram or crystalline diagram of an n-type semiconductor. So you can see here all the electrons in the valence band are 4. After bonding they will be having 8 electrons. So electron 1, 2, 3, 4, they are bonded with remaining 4 electrons in the neighborby silicon, which constitutes 8 electrons are bonded to create 4 covalent bonds. So similarly this is the bonding, and after the bonding 1 electron is extra is available in a p-type material. Similarly, coming to the structural design or construction of this p-type material, here you have the silicon, and here you are going to have the boron. So boron is an impurity which has 3 electron in its valence band. So here it is having only 3 electrons in its valence band, and it constitutes a covalent bond between these 2 electrons, and it constitutes a covalent bond between a nearby a silica again. So this have a covalent bond here, and here also you have one more silica, and it's having 1 electron, and it's created a covalent bond. And here you see here only 3 electrons available. Here you have one hole which is an vacant. So here you have a hole as extra, and here you have an electron as extra. So this electron will try to move into the p-type material, filling the hole. So this is how a depletion region is created. So now we are going to call this region as a depletion region. So coming to this depletion region, so now the things are very clear here. So in we have n-type semiconductor separated by a barrier or depletion region, and you have a p-type semiconductor. Here you have one extra electron, and here you have one extra hole. So this depletion, so this electron will try to move into the hole, and there is no further movement of electron, and it creates a layer or immobile layer which is called depletion region. So this is the actual PN junction diode. So actually now what we are going to do is here you are going to have the sun energy, and your sun is going to incident the irradiation on the depletion region. Then it tries to generate one extra hole and one electron. Like this, more number of holes are created, more number of electrons are created, and all the electrons will try to will be available at n-type semiconductor. All the majority carriers will be available at this side, and you can see the availability of electrons is very high. Similarly, at p-type, more number of holes will be available. So automatically, so due to this depletion region here, when this depletion region is getting affected by solar radiation, you can have more number of electrons are available and more number of holes are available. So this will constitute as a positive charge here, and this will constitute a negative charge here. Now when you connect, the type of supply generated by the solar system is an DC supply, which has positive polarity and negative polarity. And now we are going to connect this to an bulb. We are going to connect to an bulb, and automatically you can see here. So it will have the total energy absorbed in the bulb, and all the extra electrons will try to move from positive terminal to the negative terminal. They move from positive terminal to the negative terminal, and all these holes will try to combine with this, all these electrons will try to combine with this hole, which constituting the generation of electricity. So now the clarity is the type of voltage generated in a solar PV system is an DC voltage. So generally this voltage will be in the range of 12 volts or 24 volts or 36 volts or 48 volts. Generally for solar system, we consider 24. When you connect two panels in series, it will constitute 24 volts. When you connect three panels in series, 36 volts. When you connect four panels in this, it will constitute 48 volts. So hope the class is very clear. Let's try to see the diagrammatical analysis of this diagram. So you are very clear about it. So this is the crystalline silicon, and from this silicon we are going to create an solar cell, and all the solar cells are connected in series connection, which will try to develop a solar panel. So this is what the internally a solar cell consists of. So coming to how this depletion works. So this is the diagram which indicates everything, and if you see here, this is called as depletion region, and here you can see here more amount of electrons are available, and you have more amount of holes. All these electrons will try to move through an resistive load, and they develop some potential voltage as positive voltage as well as negative voltage. That's how a solar panel will generate a DC voltage. So this red color line is nothing but a depletion region, and when you subject this with solar radiation, automatically it will create more amount of higher majority of electrons here and higher majority of holes here. Therefore electron will try to move from high potential to low potential, developing an DC voltage. Actually this is the working principle of a solar panel will work. So if you feel the video is very useful to you, please like, subscribe and share with your friends such a way that which will help us to do more videos. Thank you.